Hello everyone, I am Divya, your math facilitator. In this class, we shall learn exercise 8.4, question number 10. Okay, so I hope till question number 9, everything is clear for you. Okay, so go by the logic. I am repeating it again. Go by the logic, understand the logic. From the question, from what you have to do, you have to take the steps. Clear? So you should not memorize the steps. From the question, you have to take the steps. So now next question, question number 10. In an equilateral triangle ABC. So you have an equilateral triangle ABC. This is ABC. So D is a midpoint on side BC. So D is midpoint. So D is nothing but the midpoint on side BC. Okay. And BD is equals to 1/3 of BC. Okay, D is a midpoint on side BC and BD is equals to 1/3 BC. Clear? Sorry, D is a point on side BC. Just see here better. Read the question properly. Okay. So I have read it as midpoint. It's not actually midpoint, it is point. Okay, see, please refer to the textbooks once again. In an equilateral triangle ABC, D is a point. D is a point on side BC. So somewhere you have this point D. Now this point D, now this BD is equals to 1/3 BC. Okay. So now you have to prove that. To prove, you should prove 9AD square is equals to 7AB square. So this is what you have to prove. Now D is the midpoint, so you have to prove 9AD square. D is a point on BC, you have to prove 9AD square. That means I should join this AD first. Okay, I'm joining AD first. And now I'm also dropping a perpendicular, okay, from point A to BC. Now you know that in equilateral triangle, perpendicular is nothing but the altitude, isn't it? So we call it altitude. So altitude and the median both are same. In an equilateral triangle, altitude and median are same. Okay, we have learned this concept in the other question also, and I even derived it and showed you why altitude and median are same. Do you remember? Please check out the previous classes once again. Revision is really important. Okay, so this altitude is, you are dropping the altitude on base at a point E. Okay, so now the altitude is also the median. So E is what is called the midpoint. Clear? So here, proof, what are you taking first? AE is perpendicular to BC and E is midpoint. Okay, why? Because of the reason I just gave you here, isn't it? So this is what you have. Now, just see what you have to prove. You have to prove AD square. AD square. Okay, so I am considering this triangle. Since I have to prove AD square, just see. AD is here. So I am considering this triangle. Here, this is a right angle triangle, isn't it? With respect to AD. So just see AD square using Pythagoras theorem in triangle ADE. Now why are we considering? Because in the question you have AD square. AD is this. So AD square is equals to AE square plus DE square. Okay. AD square is equals to AE square plus DE square. Clear? So that is equals to AE square. I am writing AE square. See here. What is AE square? AE square is nothing but the altitude. Yes or no? So in this altitude, here you can see, I can write this A square as, see here, A square I can write it as AB square minus BE square. Okay, I'll tell you how. Since in triangle ADE, okay, it is a right angle triangle. So AB square is equals to B square plus AE square. So I can write A square is nothing but AB square plus AB square minus B square. Isn't it? AB square minus BE square. But what is AB and BE? Better see, if I am taking this side as A units, this side as A units, this is also A units. Now E is a midpoint. So what is BE? BE is nothing but A by 2. Yes or no? B is nothing but A by 2. This complete is A. BE, E is a midpoint. So BE will be A by 2, half of A, isn't it? So if I substitute here, this is A square, AB is A, minus BE is A by 2 whole square. So how much will you get these steps? We will do it here. Okay, plus. So AE, I wrote it as this. A is nothing but AB square minus B square. Okay. So these steps I will write there. Okay. So this is the reasoning. Hello. There is no rule that you have to write it in this order only. Only thing is that so you have to write each and every point, and reasoning is very important. In the brackets you have to write since. Why did you write that step? Since, because this is the reason I have written this step. Like here I wrote this is the reason. Why did I write A square is equals to AB minus AB square minus B square? Because in triangle AB this is the reason. Okay, using Pythagoras theory. Now see DE. See this DE. How can I get DE? See, DE. So just see here, DE I can write it as BE minus BD. See, I have this is B, this is point D. I want a DE. DE I can write this as complete BE minus this BD. Okay, from this B, if I subtract BD, I'll get DE, isn't it? So I'm writing BE minus BD whole square. Got the point? Okay. So that is equals to, which is nothing but we are converting everything into AB. Okay, we are trying to convert into this form. Okay. Now see what you will get. So AB square minus B square. As I told you, AB you can take it as A square. Okay. Minus BE you can take it as A square by 2. Isn't it? A by 2 whole square. Just now I told you here. Okay. BE is nothing but half of AB. Right? So you can take it as a square minus a square by 2, or else you can write it directly as a square, and BE you can write as see here. AB is equals to BC. Yes or no? This is an equilateral triangle. All the three sides are equal. So I'm just taking these two sides. AB is equals to, now BC is, what is BC? BC, see here. So BC, E is the midpoint of BC. So I can write BC as 2 times BE. Okay, or BE is nothing but AB by 2. Getting the point? So if you're feeling these are complicated, you can just simplify it in this way. Okay, so these are the same steps, but I wrote it in the form of AB. Here I'm writing in the form of A square minus A square by 2. Clear? So whichever is easy for you, we shall follow that. Plus, what is BE? See here, what is BE? BE. BE, you wrote it as B is nothing but AB by 2, or you can write BE as A square by 2. Yes or no? B is half of BC. BC is A, so B is A by 2. Minus, okay, BE is A by 2. Minus, what is this? BD. Where is BD? See here. BD is 1/3 BC. You have BD is 1/3 BC. So it is 1/3. But what is BC? BC is A units. Yes or no? Clear with this point? So since BE is half of BC, that is half A, and BD is 1/3 BC, which is given, that is 1/3 BC is nothing but A units. Clear? So now we shall solve this. So you are getting AD square is equals to, see here, A square minus A square by 2, 2 square is 4. Okay, plus you have, let's take LCM here. So you will get 3A minus 2A upon 6 whole square. Right? So that is equals to, here let's take LCM, 4A square minus A square by 4 plus, so 3A square, 3A minus 2A is 1A divided by 6 whole square. So 3A square upon 4 plus A square upon 36. 6 square is 36. So here LCM is 36. So what will you get? 4 9s are 36. So 3 9s are 27 A square plus A square. So it is 28 A square is divided by 36. What is this? AD square. AD square you got it as, see here. AD square you got it as 28 A square by 36. Clear? So cancel it out. So 2 14s are, 2 18s are, 2 7s are, 2 9s are. So AD square is equals to 7 by 9A square. Send 9 to the other side, you'll get 9 AD square is equals to 7A square. But what you have to prove? You have to prove 9 AD square. See, 9 AD square is equals to 7 AB square. Here A is nothing but any side, isn't it? A is nothing but any side. So instead of A, I can write AB. Yes or no? So it is 7 AB square. Got the point? Since AB is equals to BC is equals to CA is equals to A units. So instead of A, you can write this. Clear, beta? So firstly, I have to prove 9 AD square is equals to something. So I'm taking this triangle ADE. In this triangle ADE, A square, AD square is equal to A square plus D square. But what is A square? Now take this triangle, you want the value of A. So A is nothing but AB square minus BE square. You have the value of AB, you have the value of BE. AB is A units, B is half of AB, or you can say half of BC. Okay, that means half of A units. And what is this BE? BE you can write as, see here, D you can write as BE minus BD. BD is one third BC. It is given to you. We have to use it, isn't it? So BD is one third BC and BE is half of BC. So half of BC is nothing but A by 2 and one third BC is nothing but A by 3. Here I gave the reason. Okay. Now solving this, you'll get the answer. Question number 11. So in the given figure, ABC is a triangle, right angled at B. Okay, so you have a right angle triangle A, B. So you have, this is B, this is E, and this is 90 degrees. Clear? So ABC is a right angle triangle, right angle at B. D and E are points on BC, trisect it. Okay. So B and E trisect the side BC. So what is the meaning of trisection? So this is BC. So D is trisecting BC, which means it is dividing BC into one, and this is two parts. E is also trisecting BC. That means this is 2 is to 1 part. In coordinate geometry, we have learned trisection means 3 parts. Tri means 3. So D is dividing this BC into 3 parts, 1 is to 2, and E is dividing into 2 is to 1 ratio. So now if you clearly observe, yes, let's clearly observe. So BD is one part. Now here if you see, these are two parts. Now out of these two parts, EC is one part. That means this is one part. So remaining DE is one part. Clear? Getting the point? Just see here, out of BC, PD, this is one part. Okay, this complete thing is two parts. But you have a point E, and now this EC is one part. So out of DC is two parts. Out of two parts, EC is one part. So what about DE? DE is also one part. That means BD is one part, DE is also one part, EC is also one part. Getting the point? Okay, that means each of it is equal. Suppose if BD is X, DE is also X, and EC is also X. Got it? Yes. So that is very important point which we are going to use it here now. Clear? So let's start solving now. So let's read the question. In the given figure, ABC is a triangle, right angle at B. D, E are points of trisection. Okay. And you have to prove what you should prove. Just see. To prove 8 AE square is equals to 3 AC square plus 5 AD square. Okay. So 8 AE square is equals to 3 AC square plus 5 AD square. So let's begin now. So firstly you have which triangle, what you have to prove on the LHS? 8 AE square, which means which triangle will you take? Just guess it, which triangle will you take? Since you want 8 AE square, see here, I'll highlight and show you. See, AE is this. Yes. So which right angle triangle are you able to form with this? Yes. So this is the right angle triangle. ABC is the ABE is the right angle triangle. Yes or no? A is the hypotenuse. Right angle is at point B. Yes. So let's start solving now. Sure. So in triangle, see, in triangle ABE. Okay, in this triangle ABE. Okay. So let's solve it. What will we get? Just see. So in triangle ABE. Using Pythagoras theorem, you will get AE square is equals to AB square plus BE square. Here. So let's move on to the next triangle. So let's take one more triangle. Here you have ABD is also one triangle. Okay, so let us take that triangle also. In triangle ABD, okay, you have AD square is equals to AB square plus BD square. Okay. Now let's take one more triangle. What is that? Another triangle you have AC. Okay, so in triangle ABC, the bigger triangle, what will you get? AC square is equals to AB square plus BC square. Okay, so three right angle triangles are formed, so three Pythagoras theorems are written. Now what you have to prove? Okay, you have to prove AE square is equals to 3AC square plus 5AD square. Okay, so what am I doing is from the proof itself I am taking this AE square to RHS and I am rewriting this. You have to prove that this is 3AC square plus 5AD square minus 8AE square is equals to what? So if you take AE square to other side, it becomes minus 8AE square is equals to 0. So if I can prove this equal to 0, so I'll prove this, yes or no? Yes, so I'm taking I'm taking the LHS. 3AC square plus 5AD square minus 8AE square. So this is equals to 0, you have to prove. Clear? But just see what is 3AC square. See here. What is AC? AC is AB plus BC. So I'm writing 3. AC square is nothing but AB square plus BC square. Plus 5. What is AD? AD square is nothing but AB square plus BD square. It is AB square plus BD square. Plus, you have minus, isn't it? Minus 8 AE square. AE square is nothing but AB square plus BE square. Okay, now expand this. What will you get? So you get 3AB square plus 3BC square plus 5AB square. There may be other methods to solve this also. There are other methods to solve this, but I am choosing the easiest method, okay, which you will understand. So this is 5AB square plus 5BD square minus 8AB square minus 8BE square. Yeah. So this is nothing but, see here you have 3AB square, 5AB square. 3 plus 5 is 8 and minus, so plus 8 minus 8 becomes 0. So 0 AB square it is. Now you have 3BC square. What is left over? 3BC square plus 5BD square minus 8BE square. If you just observe, I just gave you the division. See, 3BC square. BC is nothing but this complete thing. Plus 5BD square. BD is this minus 8b square. B is this. That means it is now completely dependent on this base. Yes or no? Okay. And I told you that this base is divided into three equal parts. BD is one part. So I'll draw it here. So B, E, E, C. BD is X. DE is also X. And EC is also X. Now BD is X. What about BE? B is X plus X is 2X. Now what is BC? BC is x plus x, 3x. Okay, so that is what we are going to substitute here. We shall substitute here. So 3 times what is BC? BC is 3x. And you have a square. So 3x whole square plus 5 times BD. BD is x. So 5x square minus 8 times BE. BE is 2x. Okay, so 2x whole square. So 3 times 9x square plus 5x square minus 8 times 4x square. So multiply now. So it is 27x square plus 5x square minus 32x square. So 27 plus 5 is 32 minus 30. So you are getting 0. Okay. So what did you get 0? You got this one 3ac square. Therefore 3ac square plus 5ad square minus 8 AE square, you got it as 0. So send AE square to other side. So you'll get 3AC square plus 5AD square is equals to 8 AE square. Do practice this problem once. It's very simple, but It looks complicated, but it's simple. Okay, so two practice points. So let's move on to the next question, question number 12. So question number 12 states that ABC is an isosceles triangle. Okay, so you have an isosceles triangle ABC, right? And right angle at B. So this is right angle B, this is AC. In the other question also, in the previous questions also, I told you if you have a right angle isosceles triangle, then what are the equal sides? Isosceles triangle, two sides are equal. So which two sides are equal? These two sides will be equal because hypotenuse is the longer side. Yes or no? So that is one point which you have to remember. Now see, similar triangles ACD and ABE. Okay, on AB you have a similar triangle which is constructed ABE, and on AC you have one more triangle which you are constructing. Okay, so that triangle is nothing but ACD. Okay, so this is ACD triangle and ABC triangle are constructed. Okay, on sides AC and BC. So find the ratio between the areas of the triangle ABE and triangle ACD. Here, so here one more thing you have to remember is these two triangles given ABE is similar to triangle ACD. Okay, these two are similar triangles. ABE and ACD are similar triangles. Okay, so what about the ratio of the sides? Their ratio is equal. Okay, or you can say the sides are in proportion. Clear? So let's start the proofs. So now ABC is a right angle triangle. Yes or no? So this is an isosceles triangle. So this side I am taking it as A and this side also as A, since these two sides are equal. So what about AC? See here. AC square is equals to AB square plus BC square. In which triangle? In triangle ABC. AC square. AB square is A square and this is also A square. So you will get 2A square. So what is AC? AC is nothing but root over 2A square. You can write this root 2 into root A square. This is nothing but root 2A. So AC I got it as root 2A. Clear beta? AC I got as root 2A. Now using similarity of triangle concept. Yes. So here we have to prove that. See, find the ratio of the triangles. Find the ratio of area of triangle ABE divided by area of triangle ACD. Okay, so this is one theorem which is deleted for you. I told you this theorem is deleted, but just have an understanding, and I introduced this theorem for you in the concept class. Do you remember? I told you area of two similar triangles, ratio of area of two similar triangles is equals to the square of the ratio of the corresponding sides. If you don't remember, go back to that class. Watch that class once again. Concept introduction class is very important. Okay, you even if the syllabus is deleted, some or the other point you may get it. Okay, so knowing the point is very important. Even if you don't know it deeper, it is important to know the basic. Okay, so AB. So what is AB? So we know that ratio of areas of similar triangles is equals to the ratio of the sides. Ratio of the square of the sides. So what are the sides here? Side of triangle ABE. ABE side I am taking this AB. Okay, in this triangle ABE. So in this triangle ABE, I am taking this side. Okay, AB is nothing but A units, and in this triangle ACD, I am taking this side. Okay, I will take AC side because I have the value of AC, isn't it? See here, you got the value of AC. So that is equals to AB is nothing but A divided by AC is what? AC is root 2A. You have whole square. A and A gets cancelled. So what is remaining? So area of triangle ABE divided by area of triangle ACD is nothing but 1 by root 2 whole square, or the same thing you can write as 1 by root 2 whole square is 2. Okay, so ratio is 1 by 2 or ratio is 1 is to 2. The same thing you can write as 1 is to 2. Okay, so let's move on to question number 13. Question number 13 is again the similar question. Equilateral triangles are drawn on three sides of a right angle triangle. So you have a right angle triangle in this way. Okay, so this is A, B, C. Equilateral triangles are drawn on three sides of the right angle triangle. So here you have an equilateral triangle. Okay, here also you have one equilateral triangle. Here also you have one equilateral triangle. So one simple property I told you, all equilateral triangles are similar to each other. Why can anyone say all equilateral triangles are similar to each other? Why? So when can you say two triangles are similar? When all angles are equal or sides has to be in proportion, isn't it? So here all angles of an equilateral triangle are how many? All the angles are equal to 60. So if in one equilateral triangle all angles are 60, in the other equilateral triangle also all angles are 60. So since all angles are equal, so when all angles are equal, you can call the triangles are similar. Clear better? Okay, so here I am drawing triangle. So this is P, this is R, this is Q. Since it is equilateral, these sides are equal. Here these sides are equal. Here these sides are equal. Okay, and the three triangles are similar. I gave you this point, isn't it? So remember this point. Sure. So now we have to prove that. So show that the area of the triangle on the hypotenuse. On the hypotenuse, what is the triangle you have? This is the hypotenuse, isn't it? So on the hypotenuse, you have triangle ACR. So you have to show that the area of this triangle ACR is equals to the sum of the areas of the other two triangles. Other two triangles are these two, isn't it? So sum of the areas of APB plus area of triangle BQC. This is what you have to prove. Okay. So one more important point is all the triangles are similar to each other. So you can take the ratio. Okay. So ratio of the sides. You can use the theorem which I just told you here. We have used, isn't it? So ratio of the areas of similar triangles is equals to the square of the ratio of the sides. Okay. So here also we are going to use the same. But firstly, let me find what is AC. Okay. So just see here. Using Pythagoras theorem, AC square is equals to AB square plus BC square. And since these are all equilateral triangles, triangle ACR is similar to triangle APB is similar to triangle BQC. Why? Since they are equilateral triangles. Okay. So when these two triangles are equal, firstly let us take these two triangles. So area of triangle ACR divided by area of triangle APB is how much? Okay. Area of triangle ACR divided by area of triangle APB is nothing but, see here, ACR, one side of ACR is this, AC. So I am taking this AC divided by the other side of APB. APB is one side is AB and square of this. Okay, so this is equation 1. Let's take these two triangles area. So area of triangle APB divided by area of triangle BQC is what? It is nothing but APB. APB one side is AB divided by BQC side is BC. Square of this. This we are doing using the theorem 8.4. Please, as area of similar triangles ratio. I don't know the theorem number. Whether it's exactly 8.4 or not, but please check it and learn. Okay, area of similar triangles concept. I discussed it in the concept video. You don't have to worry. I gave the theorem number also there. Okay, so this is equation 2. So now let's take two more triangles. Now we have taken first two, next two. Now let us take first and the third. Okay, so area of triangle BQC. BQC divided by area of triangle ACR. BQC side is BC divided by ACR side is AC whole square you have. So this is equation 3. Okay. Now let's add all the equations. But before adding here, just see. Just see. If you add equation 1 and 3, just see the bigger triangle is ACR, isn't it? The bigger triangle is ACR. You have to prove that ACR is equals to APB plus area of triangle BQC. So the bigger triangle should be the denominator. Like in the other question also in the last class I told you, if the bigger value is in the denominator, it will be easy for us to take LCM. Okay, and also if you reverse this, just see, I'll just reverse this and take. Okay, so the same thing. So the same thing which implies area of triangle APB divided by area of triangle ACR is equals to, here also it gets reversed, AB by AC whole square. So this let us take as equation 1. Here you reverse it. So area of triangle ACR you have taken the denominator only, isn't it? See here. So you don't have to reverse this. So better the concept is, just see here. So when you take LCM, what happens? Let's see. So adding 1 and 3. Let's add 1 and 3. Why am I adding 1 and 3? Because in 1 I can see in the denominator you have area of triangle ACR. Here also you have area of triangle ACR. So if I add, I may get some fruitful answer. Okay. So I'm adding this. Okay. That is the reason I have reciprocal with this. Because if I have the denominator same, here and here the denominators if I have same, I can easily add. Isn't it? And let's see here. So area of triangle APB divided by area of triangle ACR plus area of triangle BQC divided by area of triangle ACR is equals to, here you have it is nothing but AB square by AC square. I am separating the squares. Okay, AB square by AC square, and let us remove the bracket also so that we can simplify it further. Plus this is nothing but BC by AC. So BC square by AC square. Here also you see you have AC and AC in the denominator, triangle ACR, ACR in the denominator. So you can take LCM. LCM will be area of triangle ACR. Okay. So here taking LCM will be simple if the denominators are same, which is nothing but if they are like fractions. Again we will go back to the basic. Isn't it? Like fractions, when did you learn? You learned it in your class 6, class 7, but still you will be able to apply the concept. See here, since these two are like fractions, directly we can add them, isn't it? So what will you get? See here, area of triangle ABC, I am writing here area of triangle APB plus area of triangle BQC divided by area of triangle ACR is equals to, what is the answer you are getting? AB square plus BC square. Just now here I told you AC square is nothing but AB square plus BC square using Pythagoras theorem in the bigger triangle. Yes or no? So let's use it. So AB square plus BC square is nothing but AC square divided by, you have AC square. Why? Since in triangle, which triangle is ABC? ABC, AB square is equals to AB square, sorry, AC square. Hypotenuse is AC, isn't it? AC square is equal to AB square plus BC square. Okay, so these two gets cancelled. So you will have area of triangle APB plus area of triangle BQC. If I cross multiply, it is area of triangle ACR. Okay, one step I didn't write. Just see. AC square by AC square becomes 1. So if I cross multiply, this becomes 1 into ACR. So this is the final step. Here, let's move on to the next question, question number 14. So prove that the area of equilateral triangle described on the side of a square. So you have a square here. Okay, so you have one equilateral triangle on the side of a square. So you have one equilateral triangle on the side of a square. Okay, so equilateral triangle described on the side of a square is half the area of the equilateral triangle described on the diagonal. So suppose if this is a diagonal of the square and if I am having an equilateral triangle on the diagonal. Okay, so let's draw the triangle properly. So if I am having equilateral triangle on the diagonal, so this is how it can be. Okay, so this is square A, B, C, D. Okay, and this is point, I am taking it as Q, and this is point P. Here beta. So now you see you have to prove what you should prove. Just see. So if there is an equilateral triangle, okay, if there is an equilateral triangle described on one side of a square, so it is equal to half of the. So on the side of a square you have this triangle BQC. So area of this triangle BQC should be half of the area of triangle. Which triangle? The triangle which is on the diagonal. Diagonal triangle is APC. Okay, this is what you have to prove. So what is the proof? Again, see these two triangles are equilateral. So triangle ABC is similar to triangle BQC. These two triangles are similar to each other because they are equilateral triangles. Okay, since they are equilateral triangles. Okay, so now you see. So since they are similar, so we can take the ratio of the triangles, isn't it? So that is equals to which side we shall take? We shall take this side BC divided by AC whole square. Okay, BC is this side of this triangle, AC is this side of this triangle. So BC divided by AC whole square. So area of triangle APC divided by area of triangle, which triangle is this? PQC is nothing but what is AC? See, BC, suppose if I am taking this as A units, so it is A divided by what is AC? See here, now this is a right angle triangle. ADC is a right angle triangle. If this is A and this is A square, all the sides are equal, isn't it? So what is hypotenuse? AC square is equals to AD square plus AC square, isn't it? So AC square is A square plus A square. So hypotenuse is root 2A. So this is root 2A. Yes or no? So this side AC is root 2A whole square. A and A gets cancelled. So you'll have 1 by 2. Okay, or you can write, you have to prove that area of triangle APC divided by area of triangle BQC, the ratio is 1 by 2. So see here, so you have to prove APC, BQC is half of APC. Okay, I'm just transposing this. So just see what you have to prove. Yes, so BC is A and AC is root 2A. Okay, and in triangle APC, just see here beta, here one small mistake we have done. Triangle ABC is this, APC. So what is the side of ABC? It is AC. We have taken it as BC. Okay, that is the mistake. Okay, I'll tell you again. In triangle APC, the side is AC. Okay, I've taken it as BC. So this should be AC. The order should be same, isn't it? In triangle BQC, this is BQC. Here I should take BC. Okay, so now AC is nothing but, see here. So all these changes. So AC is nothing but root 2. AC is root 2A and BC is 2, isn't it? So this is A. So A and A cancel, so you will have root 2 whole square. Or you can write area of triangle APC is equals to 2, okay, 2 times area of triangle PQC. I'm just sending this to the other side. Or if you bring this 2 to this side, it becomes area of triangle BQC is equals to half of area of triangle ABC. So actually, as per the syllabus, you have question number 1 to 10 in exercise 8.4. Okay, so these last four problems are based on area of triangles concept, which is in 8.3 exercise. Okay, this is deleted. Okay, but I am explaining you so that you'll have some confidence and you'll have some extra information with you. Once you learn this, if you are not able to, leave it. Okay, don't spend much time on these problems. Okay, 1 to 10 are important, they are in your syllabus. The extra problems which I gave you are just for your understanding because they are mentioned in your exercise. I just wanted to give you for your understanding. But as per your syllabus, only 1 to 10 problems you have. Okay, so question number 11 to 14 are based on this deleted syllabus 8.3. So that is the reason these four questions are also deleted. Clear? So all the best. Practice this chapter again. So it's very complicated chapter. If you don't practice, understand the logic and practice it. Okay. So I'll see you all in the next class. Thank you.